All right, so for quiz number 8 review, the first couple questions you're going to see are going to ask you to find domain and range and then whether or not it's a function. There's 4 questions like this. Only 2 of them require you to write domain and range. The other 2 just ask you if it's a function. So it should be a lot easier than the domain and range problems. Okay, but let me kind of zoom into the first one here, just so you guys can get a good look at it. So what we're going to be doing is answering a couple of questions, okay? What's the domain and range, and is it a function? So let's do the function part first, okay? In order to test if something is a function, you can imagine vertical lines, or you can actually draw some, okay? Like that. And you ask yourself, for those vertical lines, did they ever touch the graph more than once per line? And the answer to that would be no, it did not touch more than once per line. That means that this is a function. Okay, so I'm going to write yes, it is a function. So that's the first part. So there's going to be 2 questions that are just going to ask you stuff like that, and that'll be it. Okay, so it should be pretty easy. But then, for this example, I also ask you to tell me if, not if, but what is the domain and the range for these functions. Okay, so I'm going to write domain, range. All right, so domain and range. So domain-wise, you're asking yourself, how far left does it go? And for range, you're asking yourself, how far right does it go? So when you're looking at your picture, you're kind of trying to say, like, okay, this graph, in terms of left and right, goes like all the way up to here, right? Like that's as far left as it goes. What is the x value for that point? Well, -2. It's a -2. So I'm going to put -2. Now, look at that point where it's at. See how there's an empty circle right there? Yeah. So that means I should not include -2. If it's a solid dot, I can include it. Okay, but if it's an empty dot right there, I'm not going to include it, which means you use a parenthesis, not a bracket. Okay, the square looking parenthesis. That's the one that means included. Okay, but -2 is not included. Now, how far right does it go? Infinity, right? Because you're looking at this arrowhead, and this arrowhead means it's going to keep going up and to the right forever, right? So it's going to keep moving to the right forever. So I'm going to write positive infinity here just to kind of keep it with the Desmos assignment. And remember, the infinity, the value for infinity or negative infinity is never included, so you always put a parenthesis around it. Okay? Now the next part says range. How low does it go? -2. Right here on the y-axis, you guys see -2. There's no gap, there's no break, there's no empty dot right there. So that means you get to include -2. All right, so that's -2 on the y-axis, okay, not the x-axis. So I'm going to include it. Okay, so I'm putting the bracket there. How high does it go? Yeah, to infinity, right? The arrow is going up forever, right? So we're going to say positive infinity. And remember, you're going to not include infinity, because remember, we can't capture infinity, right? It's not attainable. It's just a really big number. Okay, so there's part A. Now remember, I think question 1 and 2 only ask you for domain and range. Question 3 and 4 will only ask you if it's a function. That's it. Okay? So 1 and 2 ask you for domain and range. 3 and 4 ask you if it's a function. All right? All right, so part B, guys, part B. So let me give you a minute just to kind of draw this out really quick, and then we'll do the domain and range and whether it's a function or not. All right, so for part B, remember, I want to check first if it's a function. That's the easiest part to do, right? So I'm just going to draw vertical lines, right? So here's one, here's another, here's another. None of those touch more than once per line. So since they only touch one time per line, this is a function. What I was mentioning earlier, I don't know if you guys saw, but like a graph like this would not be a function because I could go through this multiple times and have two different places per line, right? So that would be an example. A circle would be an example of something that's not a function because I can just put a line right through the middle of it and it's going to touch two times, right? Once it touches twice or more, it's not a function, okay? But if it's only touching once, then it is a function. So I'm going to put yes, it is a function. Okay? Now, the domain and range is next. Let me write that down here. Domain and range. So domain is how far left and how far right it went. So how far to the left did this graph go?
-2.
-2. Now, should I include it? Yes, there's a solid dot there, right? So remember, we're just thinking of it kind of like an invisible vertical line right at -2. That's as far left as it got, right? So that's why we say -2. Now, how far to the right does this go? 3. Should I include it? No, because there's an open circle there, okay? So I'm going to go to 3, and I'm going to put a parenthesis. Because this open circle means it got to that number, but I can't include it. Okay? So that's why I use an open parenthesis for that. Okay? Now my range, how low does it go? -2 on the y-axis, so good. -2. Should I include it? Yeah. Now this next part sometimes tricks people. How high did it go? To 0. A lot of times people will tell me -1 because that's where they see the other point. And they're like, oh, well, that's as high as it went. There's the other point. But no, it still went higher than that, right? It's way over here. So it went to 0. Should I include that?
Yep.
Yeah, I should, because even though there's no point there, but if I zoom in, and actually, close your eyes, don't look. There you go. Now it's connected. But yeah, if I were to zoom in, that's basically where it was going to be touching, was the origin, right? So a nice consistent drawing of a set of lines there, or set line segments. So yeah, it's there. It may not have a big circle, like solid circle on it, but as long as there's no gap there, right, or no cut or anything like that, you can include it. So I am including that value. Okay, so from -2 to 0. All right. So, and by the way, today's stuff that we're doing, I am taking my time with it because remember, we're doing 3 different lessons today. Okay, or 4 different lessons. So the stuff that we just did was section 2.8. Okay, 2.8. Now, for your inverses, you guys have to remember this is a 5-step process. Usually very quick though, right? The first 3 are pretty quick. The 4th one takes a little bit of time. The 5th one's pretty quick. Okay? But we're going to find the inverse for each function. You only have to do 2 of these. So after we're done with these 2 examples, that's the whole front of your quiz. Okay? There's going to be 4 graphs, 2 of these. 2 of the graphs will say what's domain and range. 2 of the graphs will say are these functions, and then we're going to have 2 of these problems. So here's how you go about doing the 5 steps. Okay, step number 1, which is actually not required. It really depends on whether or not you have to write your own problem. But step number 1 is write the original equation. Well, there it is. It's already done. Okay. Step 2, change your function notation to a y. So instead of h of x, I'm going to put y. Okay, so y equals -3x minus 2. Okay, so that's the second step. Third step, just change like magic your y to x and your x to y. So I'm just going to rewrite it. X equals -3y minus 2. Step 4 is the hardest of the steps. Not to say that it's difficult to do, but it's going to require the most work. You're going to solve for y. Solve for y. So let's add 2 on both sides. So I get x plus 2 equals to negative 3y. Now, I'm going to divide everything by negative 3. Okay? After I divide everything by negative 3, I get a negative 1/3 x. You could also write negative x over 3 if you want to. I just like to write the fraction. Negative 1/3 x minus 2/3 equals y. Now do me a favor. Don't write that y that I just did right now, but go ahead and look at it. Okay, so it's negative 1/3 x minus 2/3 equals to y. Now the last step says, get the y that you just solved for and rewrite it as your inverse notation for that function. So there you go. There's my answer for part A. Sometimes these problems take a little bit more time because of step 4. Okay? Step 1, writing the equation, no big deal. Step 2, rewriting it, y equals, that's not a problem. Step 3, change x to y, y to x, that's easy. Step 4, that's the one you work at. Okay? And then step 5, just rewriting your inverse instead of y is also not terrible. Okay? It's not a terrible thing. So that's part A. Okay, let me kind of show you guys that answer in case you can't see it from where you're at. And then I'll go back up to do the other one. And again, you guys could write negative x over 3 or x over negative 3 and just leave it like that. That's okay. But it's just I prefer to write the fraction that's in front. So negative 1/3 x. That's my preference. But you don't have to do it that way. You can write x over negative 3 and that's fine. You should not get the wrong answer for that. Okay. Now on a state test, they may not write x over negative 3. They may write negative 1/3 x. So you got to just make sure you know that they both mean the same thing. Okay. So just be aware of that. All right, so part B. Same steps, okay? Write down your original function. Done. Rewrite g of x to y. So this is y equal to 4x minus 1 over 2. Okay? Change your x to y and your y to x. So this will be x equals to 4y minus 1 over 2. Okay? Next step, solve for y. So in order to solve for y, we're going to multiply everything by 2, or I guess just move the 2 over if you want to do it that way. So 2 times x, that's 2x, equal to 4y minus 1. Again, my objective is to solve for y, so I'm getting there. Okay, it's taking a little bit of time, but I'm getting there. I'm going to add 1 to both sides. Plus 1, plus 1. Now, in doing that, I'm also going to take my work over to the right, okay? So let me move this over. So 2x plus 1 is what I have right now on the left side, and on the right side I have 4y. So I'm almost done. Got to get y by itself. Let me divide everything by 4. So 2 over 4 is a half. X plus 1/4 equals y. But my last step after I solve for y says change your y to the inverse notation. So instead of writing y, I'm going to write g inverse of x. And there's my solution for that one. Now I know we got fractions and stuff like that. People start to worry about the fact that we get fractions. It's okay. We're not doing anything with the fractions. We're just writing them out and stopping, right? I'm not having you plug it into anything. So hopefully it's nothing that's going to look a little scary to you. But it's just they come out, write them out, and you're good. Okay? So again, this is the whole front of your test, the front side. Okay? The back side is not so bad either, but at the very end we get some tougher problems. All right? Any questions on the front side of this test? The whether it's a function or not, domain and ranges, inverse functions, anything like that? All right, so let's look at these problems. So let me give you a minute to write down the instructions, and then I'll continue. So again, does the system of equations have one solution, no solutions, or infinitely many? Here's how I would recommend you do it. Okay, so look at part A. I did this in our notes when I taught this to you guys. I told you to write these things down in this order. Okay, and check them in that order. So first of all, for part A, do these have infinitely many solutions? In order for them to have infinitely many solutions, what do the equations have to look like?
The same.
The same. They got to be identical. Same slope, same y-intercept, and everything. Those are not the same. So this is not an option. Okay? Then you say, okay, in order for these equations to have no solutions, what kind of lines do they have to be? Well, they have to have the same slope, but those type of lines are called parallel, right? In order for no solutions to exist, or I guess not exist, they need to be parallel lines. And if they're parallel lines, they need to be exactly what you said, have the same slope. If you look at these two equations, they do not have the same slope. One has a slope of -2, the other one has a slope of half. So since they don't have the same slope, then it's none. I mean, not none, it's one. It's the last one available. And if you look at the notes I gave you, for one solution, I specifically said the slopes are not equal, right? That's how you can tell when it has one solution. The slopes are not equal. If you look, those slopes are not equal. So there you go, all right? So always check IMS first, usually the easiest. Are they identical? Then check none, because you're asking if they're parallel. In other words, do they have the same slope? And if they do or don't, then move on to the one. And that should be the only option left if the first two cancel. So for part B, notice I'm going to do IMS, none, one. All right, so are these an infinitely many solution type of equations? No, they're close, but they're not. Are these parallel?
Yep.
Yeah, so that means that the answer is no solution, right? They're parallel because you can see that their slopes are both 4, but their y-intercepts are not the same. If they were the same, then they would be an IMS problem, okay? But since they're not the same, but you got the same slope, it's a no solution problem. Remember, if that one would have not worked, then you automatically circle 1, okay? And I mean, you don't have to do it this way. I just find it more just strategic, going from easiest or most obvious to note to more complicated, right? So you'll have 2 of these on your quiz tomorrow, the very first 2 at the very top of the back page. Okay? Solve each system by graphing. Solve each system by graphing. Let me give you a little bit of time to write this out. Okay, so for these problems, what you're going to have to do is obviously graph your functions. I'm actually grabbing my a card from my wallet here, my Barnes and Noble's educator card, and I'm gonna use that to graph these equations. Okay, just to try to use something like a straight edge. So this should be just fine. So we'll start with the top equation right here. Okay. Now I'm gonna put a little red dot right there so I know which one is which. I know that my b value is 4 and my m value is a -1 over 1 according to that one, okay? So I'm going to start at +4 on the y-axis, and I'm going to go 1 down, 1 over, because that's my slope, right? -1 over 1. And let me use a straight edge here to the best of my ability, and I'm going to draw it out. It's a little hard because on this surface, these cards slide, but that's not too bad. Okay, so there's one graph. All right, my other one, I'm going to put a little blue dot next to it just so you know that I'm graphing the 2x minus 2 now. My b value is -2. My m value is 2 over 1, right? So I'm going to start at -2 on the y-axis, and I'm going to go up twice, over once. Okay, so starting at -2, and I'm going to go up twice, over once. That's right here. And then I'm going to use, again, a straight edge to try to draw my line. Whoops, I kind of missed that there. All right, let me zoom in so I can show you what I meant about this being one of the worst ways to find answers. Now, if you had to give me that point, you would probably say it's about 1.7 for x and about 2.1 for y, right? But then someone else might say, well, I thought it was 1.8 and about 2, right? Your line is going to look completely different than my line because our lines can be crooked, right? And if our lines are crooked, then that's a little bit more of a problem.
College year.
Now notice, guys, when I drew my blue line, do you see how I kind of missed that point on the top right blue dot? I kind of went way too far to the left, right? If I would have drawn it a little bit more to the right, maybe I would have gotten a better answer. But here's the thing. Doesn't matter how you drew it, okay? You just got to give me the correct value where you cross. So I'm going to say that I got to about 1.6 comma 2.1, and that's going to be my answer. Okay? Whether that's the real answer or not, I don't know. But I do know that according to my picture, that's the answer. And if you were to do the same thing I did, I'd give you full credit. If you drew the wrong lines and you intersected somewhere else, let's say you intersected like down here, okay? So I'm going to take away points because you drew the wrong lines. But I'm going to give you full credit for the points if you tell me your point of intersection, where they crossed. Because remember, I'm checking to see if you understand this idea, okay? To prove to me that you understand solving by graphing, you have to graph lines, and you have to tell me right where they cross. That's the answer. So even if your lines are wrong, I can still give you partial credit for at least labeling the right point, or the point where they crossed. Maybe it's not the right point, but it's the point where they crossed. So at least give me that right. I can give you like 50% credit on that problem. All right? That doesn't mean you should go into these, just draw anything random and say this point, right? Try doing the right thing. But if you mess up, as long as you label your point properly, I can give you at least half credit for that. Okay? Any questions on this one? Again, this is the worst way to solve. Okay, and this is a perfect example of why it's the worst way to solve. Okay? Because your line will give you tons of different answers based on the angle that you use, whether you messed up on your straight edge, all that stuff. All that can be messed up. So just be careful with it. All right, last one. Solve each system by substitution. Now you'll notice these are a little bit on the harder side because they're not solved for y already, right? When they were solved for y, we said those were the easier ones. So these are in standard form, so you're going to have to do it yourself. Okay? So you could choose to solve for y on the left side, or even solve for x on the left side. Or you can choose to solve for x or y on the right side. Okay? I asked my first period class, and one of my students said, I asked them which one seems like it would be easier. They said left. And I said, okay. I said, I would have chosen the right, but I'm going to go with your way. And they're like, no, choose right. I'm like, no. It doesn't matter. It's still correct. Just do the work right. And it actually turned out that their choice would have been easier. So it was. And I told them, I'm like, actually, your choice was better than the other one. But what would you guys like me to do? Left or right side to solve for a letter?
Right.
Right side? Okay. Again, I would have chosen that, but I found out the other way was actually a little bit simpler. But it doesn't matter. We'll do it either way. So we're going to go with the right side, and we're going to solve for x or y. Well, y looks like the easier one, right? It doesn't have any numbers next to it. It does have a negative, so you got to be aware of that. I'm going to subtract 4x on both sides. So I get negative y equals negative 4x plus 2. Now to get y all by itself, I'm going to divide everything by negative 1, okay? So I get y equal to 4x minus 2. Here is the equation that I just solved for. This is the one I'm going to plug in to that y right there. All right. Again, it doesn't matter which side you start with, whichever one you feel more comfortable solving for. It's up to you. I could have solved for x on the right side if I wanted to. Okay, I don't know why I'd want to, but if I wanted to, I could do that and then plug it in. You're still going to get the same answer as long as you do the math right. So let's go ahead and plug it into the other side here. We got 2x plus 2 times y, which is 4x minus 2, equals to 6. Okay, remember my y value replaces, or sorry, the 4x minus 2 replaces the y value in that other problem. Now distribute. So we get 2x plus 8x minus 4 equals 6. Now start simplifying. 2x plus 8x, that's 10x minus 4 equals 6. Let's move that negative 4 to the right side by adding. So that's 10x equals to 10. Okay? And now divide everything by 10 and you'll have your x value. Now remember what I told you guys. Do not take this as your solution and run, okay? I wrote this in the beginning of section 3.2 notes. I said, every system of equations solution is a point. I just found half of the point, the x value. I got to find the y value. But that doesn't take too much longer. I'm just going to plug it back into that one. I'm going to let x equal to 1, plug it in, and then I'll solve. So y equals to 4 times 1 minus 2. Well, 4 times 1 is 4, and 4 minus 2 is 2. And there, I'm done. Now remember, if you leave your answer like that, I'm going to be nice and I'll give you full credit for it, but it's really supposed to be a point. You should really write it like this. Okay? Eventually, I will take away points for not writing it as a point if it has to be. But for now, I'll kind of glaze over it and be like, okay, you got it. But just don't forget to write it as a point. Okay? But it should look like a point. Right, so this is the review.